Hey guys, this is Sai from BreVITy and I'm here to talk about intersection of two linked lists, which is one of the famous problems in two-pointer method in the realm of linked lists. So I guess Fireboy and Water Girl will meet. If you don't understand what I mean, go check out Vignesh's video, link will be given here. That will give you an idea of how do you approach a section of two linked lists using the two-pointer approach.
Exactly. Let's explore why.
Okay, so when we look at this problem, I have one method coming onto my mind, like where we use a visited nodes, I guess. So like you have a list of nodes where you keep track of these nodes, whether they have been visited or not from the first linked list, and then when you traverse through the next linked list, and then you see whether the second linked list nodes are present in the visited nodes list or not. So if it is present, that means at that point there has been an intersection, because you in a set you keep on adding in an ordered fashion, and then you take the next linked list and then you see the intersection point, if those both are the values in those both nodes are same or not. So that's one point. Probably like it is actually a good method, but probably since we are in the two-pointer week, so let's try to understand how two-pointer method we can inculcate in solving this problem. Okay, so getting into the code now, we know that we need two pointers. So let's initiate those two pointers, like I equal to head A, that is pointing to the first node of the first linked list, and J equal to head B, so which is the second pointer pointing to the first node of the second linked list. And now we run a while loop, like while I is not equal to J. So if I is equal to j, you have to break out of the loop, you have to return, or else you have to just go on incrementing, right? So that's what we had discussed. So let's see if I yeah, so now if I is either it has reached the end of the linked list or not. So we are checking if I is equal to none. So if I this condition if I will ensure that it hasn't reached the end of the list. There is no null value right now in I. So that's what if I condition means in the Python language. So if I, you do I equal to I dot next, oh sorry, I dot next, and if it has reached the end of the list, so else you have to point I to the head B, the head node of the second linked list. The same way, if j equal to j dot next, and else it's the vice versa condition. So j equal to head A, and now you simply return I. You can return j also, that's not at all an issue. Now let's see how it goes. Okay, so this is right now it's fine. Okay, yeah, probably now let's try for this case, maybe, just to be sure that our algorithm works. So you give 2 3 okay, so we have to give it in this manner then. Give it a test case 0. Now our first linked list looks like 2 6 4, and the second linked list looks like 1 comma 5, and skip A is 3 and skip B is 2. So run code. Yeah, so now I guess it should be working. Now let's try submitting it. Okay, there you go. So this was the two-pointer approach for this problem given to us, intersection of two linked list. Regarding time and space complexity of this solution, uh, the time complexity for this would be O of n, because it depends on the number of nodes in each of the linked list. So if your A list has n number of nodes, B list has m number of nodes, so n plus m, that is another constant, so you can say n plus m equal to k, so O of k, that is the time complexity. Regarding space complexity, it doesn't take any space. That's the beauty of this algorithm. So it's just O of n again, because what you need the two linked list, the structure. So for that it will be just O of n. There is no additional space complexity there. If you found this useful, probably subscribe to BreVITy for more content, and if you have any queries, probably there is a Discord server which we maintain. A link will be given in the description below. This is Sai signing out.